Hello and welcome to today's session, Streamlining Oracle Workloads from On-Premises to VMware Hybrid Multi-Clouds. My name is Sudhir Balasubramanian. I am a Senior Staff Solution Architect and the Oracle Practice Lead for VMware. I'm joined by my colleague, Ryan Kelly.
Hi, I'm Ryan Kelly. I'm a Staff Cloud Specialist with VMware Cloud AWS at VMware.
To the agenda for today's discussion, essentially we'll start by talking about the benefits of running Oracle workloads on VMware platform. We'll talk a bit about the software-defined data center, SDDC, right? Follow that up by the VMware Hyper-Converged Infrastructure, HCI, vSAN. We'll touch a bit on virtual volumes, VMware vVols. We'll also touch a bit on VMware NSX. We'll talk a bit on high availability, business continuity, disaster recovery, performance monitoring, capacity management, a bit on automation and orchestration. And we'll end it with the Oracle workloads on VMware Hybrid Cloud. We would pick VMware Cloud on AWS as the cloud of choice today, and then we'll wrap it up with a lot of collaterals. So let's take a look at the benefits or some of the benefits of running Oracle workloads on a VMware platform. Right. But even before we look at the advantages of virtualization, right? Let's first take a moment and understand what Oracle business critical application requirements are, right? And then let's understand the benefits of running these BCA or business critical Oracle workloads on a VMware vSphere platform, right? So any application, right, that's deemed business critical, it'll have certain SLAs, it'll have certain RTOs, it'll have certain RPOs. Essentially what it will have is a set of stringent requirements. For example, availability. Well, this particular application must be highly available. It must be resilient, it must be redundant, and the mean time between failures, that must be very high. The fact that this particular application must be highly performant, right? All of the processes must complete in a short amount of time or in a timely process, right? And one must take all precautions to avoid all kinds of bottlenecks and so on and so forth, right? So there are many more benefits, and these are not particular to any BCA or business critical application vertical. It essentially helps all of the workloads, right? So some of the features like resource maximization. So what happens is with resource maximization, the server resources, right? Sometimes they are a bit too much for one application instance. By virtualizing, you are able to improve the resource utilization and also enhance, the reduction of wastage. With enhanced availability, what happens is the native application HA features, they are mostly incomplete for most of the critical application. VMware vSphere HA, that feature, right, that complements the native application HA features. And what happens is you have improved availability. For example, running Oracle RAC on VMware vSphere, right? With the Oracle RAC, you get the application level HA, and running that on top of VMware vSphere platform, you get the infrastructure level HA. And if one were to, let's say, stretch that across metro distance, we get site level HA. So 3 levels of HA when one runs, let's say, stretched Oracle RAC or extended Oracle RAC across metro distance. Right. So let's take a look at this design methodology for a moment, right? And then, we typically start with the requirement gathering phase, right? And that is followed by selling the project to the stakeholders for buy-in, followed by understanding the current environment constraints, right? We then have to understand the database workload. We look at various migration strategies, which includes, let's say, big Indian to little Indian when one moves from Solaris, AIX or HPUX to x86, right? And that's followed by understanding design considerations for high availability, right? You have to understand the design considerations for DR. And that needs to be followed by backup and recovery. We need to inculcate monitoring. We need to inculcate tuning. And last but not the least, we need to keep licensing in our mind as well, right? But if we were to take a step back and look at all these steps of the design workflow, there is no one particular step, right, that is particular to any architecture, whether that's physical or virtual. So all we're trying to say here is there are absolutely no changes in the design methodology when one virtualizes Oracle workloads on VMware as opposed to running those Oracle workloads on bare metal. So keep this in mind, the Oracle workloads, they have no idea that they're running on a virtualized platform, right? And so the steps, for example, to provision the grid infrastructure, or let's say the RDBMS binaries for an Oracle database or an Oracle RAC, they're exactly the same as one would do on a physical architecture. Right. So, this slide talks about some of the performance best practices, right? Key things to keep in mind. Best practices needs to be inculcated into every layer of the stack, including the virtualization layer, to ensure that the workload, they can take advantages right? Or take advantage of the underlying stack. For example, right? Use para-virtualized SCSI controller, PV SCSI, when possible. Essentially use all four of them, right? So the reason why we say that is to make sure that there is fairness, there is load balancing, and there is queue depth balancing, and so on and so forth. So the link at the bottom of the slide, that that basically is the link to the Oracle on VMware best practices document.
So let's jump into an overview of the software-defined data center. So we're going to start pretty low in the stack at the hypervisor level, and then we'll build onto that. And the reason we're talking about this is to help to elaborate why the vSphere platform is such a great place to run Oracle databases. There's a lot of engineering and a lot of features that are built into the entire stack that are there to ensure performance as well as availability and disaster recovery for the Oracle databases. So right now we're going to start at the bottom of the stack. So in compute virtualization, software-defined storage, as well as software-defined networking. Next slide. So last year we introduced vSphere 7, and a lot of customers have quickly adopted this and upgraded to this new platform. There's a lot of new features that were put into this release that are really there to address these high performance application workloads like Oracle databases or Oracle applications, as well as just any type of high performance application that runs on vSphere. One of the main things we did was we refactored VMotion to have a lot less interruption and a lot higher performance, and doesn't impact the actual running VM when we do that. We have things like assignable hardware. We built Kubernetes into the platform, lifecycle manager, as well as security that's deep down inside the kernel of the ESXi to do things like advanced firewall and identity-based firewalling as part of our NSX platform. Next slide. So one of the key features that we have introduced in vSphere 7 that really has a lot of our database customers excited is these performance improvements to VMotion. So before VMotion, there was a little bit of an impact on the guest performance. So if your guest operating system and your database is expecting to run at 90 or 95%, when a VMotion event occurs, which could occur manually, a vSphere admin is right-clicking and doing a VMotion, or as part of DRS could just be moving all the time, there could be a significant performance hit on the VM, and it could be noticed by either some logging or some errors that occur within that application or within that guest operating system. And then there was a little bit of a stun time when we did the vMotion. So there would be, a couple seconds of ping loss from the VM that's traditional vMotion. But in vSphere 7, our engineering team has greatly improved that ability, not only on the performance impact, but on the switchover time. It's much less. It's basically under 1 second, probably just a millisecond, almost 0 to no ping time loss. So, you're not going to lose access to the application. If there's a transaction that's in progress, they're not going to see any type of CPU performance impact or any loss of connection to the application from like a web server or an application server. And then in vSphere 7, we actually converged memory and storage. So we are able to use flash-based storage to build out a flash-based array using our vSAN. And then we've done a lot of advancements as far as performance and ensuring that there's very low latency between the writes of the disk to whether that be flash or magnetic hard disk drives. And then we have a persistent memory, so PMEM, that's built in. It's byte addressable. It's only a few hundred nanoseconds or less on average for the latency. very durable. It's also very low power consumption. So if you're worried about the additional load that this is going to put on your power or cooling, we've engineered this to be, very low power. Next slide.
All right. So with version 6.5, 6.7, right? Essentially what we did was we released this PMEM, or this persistent memory feature that Ryan was talking about, right? So essentially that uses, and we are able to use the PMEM or the persistent memory in two modes, right? We can use persistent memory as a block addressable, as block storage, right? And we call that vPMEM disk. And the second mode is you could use PMEM in a DAX mode, and that's called vPMEM, right? So what happens here is, here the PMEM data store or the region store in VM kernel that manages the PMEM. vSphere allocates PMEM regions, which then can be exposed to the virtual machine, right? So as I said before, the two ways to expose PMEM. For legacy operating system or for legacy applications, we can expose that as block storage. So essentially vPMEM disk. So what happens is the NVDIMM capacity as a host local data store, right? And then the virtual disk or the VMDK of that virtual machine, that can be stored on the PMEM data store, right? And that essentially is backed using PMEM. So the guest will access a regular SCSI or an NVMe device, a block device. There is no guest operating system changes that's required here. For the second way, the vPMEM, essentially, which is byte addressable, that's only possible for modern operating system or modern applications. Here, it's exposed as the byte addressable persistent memory within the guest operating system. So some of the use cases that we ran and we did the test for, and essentially we did that with Micron PMEM, right? Some of the use cases were accelerating the performance of Oracle redo log activity, which overall will improve the overall database performance. The second use case was accelerating performance using what's called the Oracle Database Smart Flash Primary Cache, right? And the third use case that we had was essentially potential reduction in Oracle licensing, right? So the link at the bottom of the slide, that talks about the above use cases, right, with the Micron PMEM in more details. So currently we have an ongoing collaboration with Intel, right, to work on Oracle on VMware using Intel DC Optane PMEM to work on all of the use cases and much more.
So working up the stack, one of the new features that we have as well for the VCF platform on-prem as well as in the cloud is using hyperconverged storage or vSAN. So in monolithic storage, there's, traditional environments, this is back in the day to vSphere 4, even before that. What customers would do is they'd have a cluster that has either fiber channel or iSCSI that's attached to some sort of switchgear and then storage array. What we've done with vSAN is we've actually moved that storage to the hosts on flash-based arrays. So we use NVMe flash-based storage, and we carve that up into a vSAN data store. And so we provide redundancy with having multiple hosts. If one host were to fail, there's a certain RAID level that is set. So if any of the surviving hosts would be able to take over and then commit that storage. But instead of having that traditional storage array that doesn't scale horizontally as well, we have this ability to have everything converged, all the compute, memory, and storage and networking, all on the cluster nodes. Next slide.
Okay. So, this solution architecture, you can see before you, this was definitely on an older vSAN version, but the Oracle solution architecture, this architecture is still relevant for all versions of vSAN, right? So the setup is a 4-node traditional Oracle rack cluster on a 4-node vSAN hybrid cluster. And as we all know, Oracle rack requires shared devices. And just as in any traditional vSphere deployment for Oracle rack, the shared devices on vSAN as well, it requires what's called the multi-writer attribute. And that's required to enable the in-guest system leveraging cluster-aware file systems that have the distributed write or the multi-write capability or the multi-writer capability, right? So all of Oracle's on VMware best practices, for example, like using para-virtualized SCSI driver and so on and so forth, they were followed, right? So essentially, after we set up this 4-node traditional Oracle rack on a 4-node vSAN hybrid cluster, what we did is we performed a lot of tests on this particular configuration. So the test focused on the Oracle workload behavior on vSAN. And what we did was we used TPCC-like workloads. So essentially, we used SwingBench, the product SwingBench. We generated workload using 100 user sessions against this 4-node Oracle rack. We did a couple of the tests as well. And some of the other tests was resiliency of vSAN by failing the disk component, and then the VMotion, which is a very popular feature for mobility. And after we performed all these tests on this traditional Oracle rack, what we then did was we deployed an extended Oracle rack on stretched vSAN cluster. So, as all of us we know, right, some of the benefits of extended Oracle rack includes the flexibility to migrate or even balance workload between sites, and that we do it in anticipation of planned or unplanned outage. So essentially what happens is the workload that is shared between the two sites accessing a single database. With vSAN stretch clusters, the active data centers, they were separated by metro distance using vSAN, what's called the fault domain concept. And of course, that's very obvious, the storage and the network layer that's stretched between the two sites, and that makes it universally accessible from all other sites. So this deployment, the extended Oracle rack on vSAN stretch cluster deployment, that included a 2-node Oracle rack, right, physically dispersed across two sites, site A, which had 2 ESXi servers, and we call them the preferred site, and site B, which has 2 ESXi servers as well, and we call them the secondary site, right? So site A and site B are known as the data sites. The site C, essentially the witness site that has 1 ESXi server, and VMware provides an option of using an appliance for the witness site. And as I've already mentioned before, storage and network is stretched to provide the storage virtualization and layer the network adjacency, right? So after doing that, after coming up with the extended Oracle rack on vSAN stretch cluster, what we also did was we added DR to the above solution. So if we look at this architecture diagram, if we look at the solution architecture diagram here, essentially using the combination of extended Oracle rack on vSAN stretch cluster with Oracle Data Guard, that gives us a lot of benefits, right? Extended Oracle rack on vSAN stretch cluster that delivers active continuous availability at metro distance. You have Oracle Data Guard that provides you replication and recovery at a global distance, right? So near zero data loss, DR, right? Essentially, we could use that as a physical standby database with protection mode as maximum performance. So the other advantage the solution architecture provides is you can also offload your database backup to the standby database. Essentially, what happens is you then avoid a hit to the production database resources during backup. So the link at the bottom of the slide, essentially, that would take you to the solution architecture that talks in detail about the test and all of the metrics and all of the results we got. But moving on. All right. So this slide basically talks about the Oracle 12c data warehousing test that we did on vSAN All Flash 6.7. Essentially, we ran 3 different tests: OLTP workload, a DSS workload, and mixed workloads. And for sake of time, I'm going to move on to the next slide. The link at the bottom of the slide that essentially has all of the test details, right, and the metrics that you can look at.
All right, so let's switch gears and we'll talk about VMware virtual volumes. It's obviously a long-standing proven feature of vSphere. So what are virtual volumes? It's an integration framework for VMware aware storage. So it's a solution we've developed with our partners. So if you're using a VMware integrated VASA provider that is the vendor built in certain code, it can take advantage of certain features of that file system. So it can use no file system or pass-through unmap. No more pre-provisioning of the storage because it has intelligence of the ESX hypervisor. And then we can also do things like integrated replication management. So the storage array is aware of the state of the hypervisor and the guest operating system. So it can understand when is a good time to do a snapshot or a replication from that storage array.
Okay. So, some of the concerns affecting virtualization of Oracle workloads, right? So databases are different levels of criticality. They need different storage performance characteristics and capabilities, right? So, there are difficulties in cloning. There are difficulties in refreshing data from production to QA owing to the large database size. The fact that you have to meet stringent SLAs for performance with slow traditional storage, that's another important point. And the fact that database, there's a rapid growth in the database, right? So there's a need to reduce backup windows to essentially meet performance and business SLAs, right? So these are some of the concerns that affects the virtualization of Oracle workloads. But let's take a Oracle use case, right? And then let's talk about that. So generally speaking, right, any regular database operation, for example, let's say a database backup, or let's say a database cloning or data refresh, they can be triggered in 3 different levels, right? They can be triggered either at the application level, which means the Oracle database level, or they can be triggered at the VMware level, the VM level, virtual machine level, or at the storage level. So each of these 3 approaches, they offer advantages and disadvantages, right? So if we start looking at the Oracle level, right? So for example, if we take a tool like Oracle RMAN, the Oracle RMAN essentially has a very fine level of granularity. The granularity could be a data file, or could be a table, or could be a table space. But keep one thing in mind, as the size of the database grows, Oracle RMAN is not always the fastest of the tool, right? Now, when we move one level down to the virtual machine level, the VM level granularity is something that is very ideal, right? And that can be done using VMware-based snapshot technology. But there's a KB article that essentially talks about the VM level snapshots. Sometimes it may stun a virtual machine during the snapshot coalescing and deletion, right? So that's the drawback to using VMware snapshot, essentially when the database is under very heavy load and when we have a snapshot, right? Now, when we talk about the third level, the storage array level, right? The speed and the performance is much, much better than any other 2 levels, right? But what it is essentially lacking is the VM level granularity, because what happens is the operations, they happen at a storage LUN level. So what's our end goal? Our end goal is to combine the VMDK level granularity with the speed of storage array for any of these database day 2 operations, right? Whether that's backup and restore, whether that's cloning, or whether that's database refresh. So using vVol, that provides an ideal solution to the challenges outlined. So again, the link at the bottom of the slide essentially will take you to the reference architecture that talks about all of these use cases on VMware Virtual Volume using pure storage.
All right, so let's jump to networking and security with VMware NSX. So one of the advancements of NSX is this ability to have software-defined networking and security. So instead of having your traditional hardware components or hardware and physical-based firewalls and security and load balancers, we built into the actual ESX hypervisor and an additional software tool to be able to take those components and move them into the virtualization layer and be able to do things like virtual firewalls, proximity-based firewalling, as well as east-west traffic using our distributed firewall. So unlike a traditional north-south firewall-based technology, we can actually quarantine off or segment or secure VM to VM communication that may be like a VM that's on the same ESX host. For example, maybe you don't want the web server to talk to the database server or your VDI servers to talk to the vCenter server. All of that can be accomplished using our NSX technology.
Right. So let's look at this use case here, right? Essentially using extended Oracle rack across metro distance and using VMware NSX to provide layer 2 adjacencies, right? In this solution, that's what we're doing here. We're showcasing the ability to stretch an Oracle rack solution, right? Which is what is called as an extended Oracle rack between multiple data centers using VMware NSX for layer 2 adjacency, right? And with extended Oracle rack, as we realize, as we know, both storage and network virtualization, they need to be deployed to provide high availability, workload mobility, workload balancing, and effective site maintenance between sites. So NSX supports multi-data center deployment to allow layer 2 adjacency in software. To put it in simple words, stretching the network to allow VMs to utilize the same subnets in multiple sites. So Oracle Rack requires active networking from each respective site. It essentially requires all of the Oracle Rack nodes to have the IP on the same segment, And if the nodes are placed on multiple sites, then we would have to have a solution that allows the same segment in both the data centers, right? And essentially the blog here goes into details as to how we were able to deploy extended Oracle rack across metro distance using VMware NSX.
All right, so let's now talk about high availability and business continuity and disaster recovery using VMware technologies and vSphere. So we're just continuing to move up the stack now. So we are talking about our data protection technologies as well as vSphere replication and our disaster recovery tools that may be on-prem to your own recovery site or on-prem to one of our cloud providers and hyperscalers.
All right. So talking about deploying Oracle RAC on a VMware platform, essentially Oracle RAC and VMware HA solutions, they are completely complementary to each other. So running RAC on VMware platform that provides application level HA that Oracle RAC inherently gives right out of the gate, in addition to the infrastructure level HA that VMware vSphere provides simply by deploying VMware vSphere product, right? So, and by stretching this configuration across metro distance, we achieve, or we basically have what's called the extended Oracle RAC across metro distance, and we get 3 levels of HA, right? We get the application level HA that RAC provides, we have infrastructure level HA, and we have site level high availability, right? So why do customers across the world readily deploy Oracle RAC on vSphere platform? It's very obvious, right? As it offers a lot of capability, essentially high availability, rolling patch upgrades, workload mobility, and balancing. So running RAC on vSphere offers greater uptime than running Oracle RAC on a physical architecture. So let's take an example here. Provisioning new RAC nodes, it takes minutes rather than hours that it traditionally takes on physical architecture. So RAC on VMware, that's a perfect match. And the proof is in the pudding as well. I mean, we ran numerous Oracle RAC on VMware sessions, and we've been successfully doing that for the last couple of years, right? The rule of thumb to make this actually work is, there has to be 5 milliseconds or less round trip latency RTT between the cluster nodes, whether they are in the same data center or whether you are across metro distance in different data centers, right? So this is true of Oracle RAC and vSphere HA cluster. I mean, with vSphere Enterprise Plus licenses, that supports up to 10 milliseconds. But if you're deploying Oracle RAC on VMware vSphere, the RTT should be less, or the round trip latency should be 5 milliseconds or less, right? And another important point, right? Starting with vSAN 6.7 P01, Oracle RAC on vSAN, it does not require those shared VMDKs for the Oracle database to be eager 0 thick. You still need that for VMFS, but for vSAN starting 6.7 P01, you don't need that to be eager 0 thick. So they could be thin provision. So essentially, there's a lot of storage space saving when one deploys Oracle RAC on vSAN storage starting 6.7 P01.
So a proven feature that we have had available for some time is this ability to do a metro cluster, or what we now refer to commonly as a stretch cluster. This is using array-based replication between 2 geographic locations to ensure that if there was a disaster event at one location, that the surviving site would be able to bring up that environment very quickly, power on those VMs, everything continues to run and operate normally and continue operations. So this is more of a business continuity than a disaster recovery tool, but is something a lot of our customers use for databases, especially like Oracle and those kinds of operations for very business critical applications.
Right. So a use case here is to essentially use the extended Oracle RAC on vSphere Metro Storage Cluster, right, across metro distance, as Ryan mentioned, right? So this example is using EMC vPlex. So Oracle RAC manages the node across interconnect, the virtual volume that is synchronously replicated over the vPlex interconnect. And what essentially happens is EMC vPlex provides what's called a witness, and that provides the failure resiliency via storage monitoring. And the vPlex witness is a required component for extended Oracle RAC on vPlex to make sure that if you have any kind of split brain, or if you have a split brain, then it decides which part of the Oracle RAC cluster lives and which part of the Oracle rack cluster gets a reboot, right? And essentially the link at the bottom of the slide, the KV article goes more into detail about vSphere Metro Storage Cluster using EMC vPlex. Moving on.
And then a disaster recovery solution that we've had for some time, a lot of customers have utilized for on-prem to their own disaster recovery sites or from on-prem to VMware Cloud AWS is VMware Site Recovery Manager. And this is a vSphere replication-based technology. So it can use the built-in software-based replication from just your vSphere. It could be any storage to any storage, or you can utilize array-based replication. So your vendor of choice, as long as you have that technology built into that storage, you can replicate between two environments. And this is for disasters in case one site's, for example, burning a hole in the ground, the surviving site, you could power on those VMs and recover very quickly with a very low RTO. And if you don't have a disaster recovery site or you're not interested in investing in a colo or building another data center, you can utilize VMware Cloud AWS for that recovery site using SRM. So it's the same vSphere platform. It's just running in Amazon's data center, and you can use that SRM technology. It would be the software-based vSphere replication. It does not currently support any array-based replication from your hardware vendor of choice, but it doesn't matter what kind of storage you have on-prem. As long as it's vSphere and you can run SRM, we can replicate those workloads to and from, even back from VMware Cloud AWS. And then another option we have for those workloads that are consuming large amounts of storage, like in the petabytes of storage, is VMware Cloud Disaster Recovery. Unlike SRM, the recovery time is not going to be as high or as low, as something like SRM. So this may be an hour or two. So if that's not a concern, but you have a lot of storage, this is another option just to keep those costs low. So you don't have to have a bunch of idle hardware running in Amazon. You can have just everything back up to S3, and in the event of a failure, we can mount those volumes and then power on the VM.
Right. So, VMware vSphere platform that provides many tools for customers to successfully ensure that, they have business continuity, they have disaster recovery, mechanisms set in place for the business critical databases, right? So if we take a step back and look at it, right, there are three different levels, business continuity and disaster recovery that can be provided for any business critical workload, right? Oracle is no particular here, right? So the three levels are the application level, the second level is the vSphere level, third level is the storage level, right? So let's talk about business continuity, right? When we look at business continuity from an application perspective, right, that can be provided using any of the Oracle-based tools. For example, you can use Oracle RMAN, you can use Oracle Data Dump or Export Import and so on and so forth. When we move on the stack and go on to the next level, which essentially is the VMware vSphere-based business continuity, well, that can be provided using VMware snapshots and VMware clones, right? And there are some tools that can help achieve any point-in-time recovery. Right. And last but not the least, the storage-based business continuity that can be provided using storage-based snapshots and storage-based clones. Right. Now, switching gears and talking about disaster recovery, if we have to talk about application-based DR tools, well, that can be provided using Oracle-based tools, right? Oracle Data Guard is very popular, followed by Oracle Golden Gate, or one could even use any third-party application-based replication, for example, DBVisit, right? The second level of DR could be VMware vSphere-based DR, essentially using VMware Site Recovery Manager along with VMware vSphere replication or even array-based replication, right? That essentially helps protect virtual machine or a LUN or a set of LUNs from, let's say, partial or a complete site failures by replicating those VMs, a LUN or a set of LUNs between sites, right? And as Ryan mentioned about VSR or VMware Site Recovery, that provides a disaster recovery or DR as a service to VMware Cloud on AWS, right? And the second option we have, as Ryan mentioned as well, is BCDR or the VMware Cloud Disaster Recovery. That's another, DR as a service tool one could use to go to VMware Cloud on AWS, right? So essentially the choice of business continuity and or disaster recovery solution, right, adopted, that essentially depends upon the application needs. It depends upon the RTO, it depends upon the RPO, and so on and so forth, and various other factors.
All right, so let's jump into performance monitoring and capacity management using some of our VRealize suite solutions. So we're just in the monitoring and alerting as well as log aggregation and analytics to ensure all of your applications are up and performing as expected. So with VRealize Operations, you can run very quick reports. It's always monitoring your vSphere and vCenter environments. And what it's really great at doing is being able to calculate your remaining capacity and then create capacity models. So for example, if you have a customer or a application owner that says, hey, we're doing a new project, we need 6 new VMs to run Oracle, you can use VRealize Operations to understand how many new hosts or how much more additional capacity you're going to need. It's also predictive. It's a learning engine, so it can also predict based on the utilization as well as any new allocation of new virtual machines in the environment. It can predict when you're actually going to need new capacity or need to order that new hardware or new equipment.
So, I mean, one could build custom dashboard using VROps and using what's called the adapters for Oracle Enterprise Manager or Oracle standalone databases as well, right? And that's completely focused on VRealize Operation Managers and the Oracle adapter packs, right? So the management packs for OEM, they make these essential Oracle related metrics. For example, right, if one is interested in finding out what are the physical reads per transaction, right? What are the physical writes, right? What are the total physical writes, total physical reads? One could extract all of these metrics from either the Oracle Enterprise Manager, essentially, which is collecting metrics from all the satellite databases, or one could use a adapter for a standalone database and extract the metric. And what we could do is put all these metrics, right, in a, let's say, one big screen and essentially look at it. So essentially, anytime if anyone has to triage or we have to do any kind of application troubleshooting or workload troubleshooting, using these adapters along with VROps helps pinpoint these issues, right, very effectively and very quickly. So essentially, we're using VROps as well, and these adapters, predefined Oracle dashboards, are available right out of the gate and right out of the box as well. So moving on to the next slide.
And then for log aggregation, we have VRealize Log Insight. This is either an on-prem or SaaS-based solution to be able to collect not just your Oracle database logs, it's also used for collecting all of your infrastructure logs, whether that be vSphere, your storage arrays, network components, firewalls, any type of load balancer information. And all of that's aggregated into a single view that you can filter by either the host name or grouping or any other objects. Also, these logs can be forwarded to whatever log vendor of choice. So if you're using something like Splunk or another log engine, that can be forwarded to those, or we can ingest logs from those systems as well. And it's just a one-stop shop to be able to see all of your log information in one place, so you can correlate if there's patterns or if there's some sort of issue that's reoccurring. Instead of logging into all of your different components, you can just run one complete report from the single source of truth. And now let's talk about automation orchestration. So nobody likes to do things repetitively. Everyone wants to script or have some sort of single click button to be able to do so. And this falls into our cloud management, automation, orchestration of the platform. So the tool that is our flagship product for automating is VRealize Automation. This also includes VRealize Orchestrator. So it's a two-component to be able to automate not just the deployment of applications, but it could be automation around doing things like storage, reclamation, log, cleanup, anything that's a repetitive task you want to have occur regularly. But it could also be used to build like a self-service catalog. If you want to give your end users or application folks the ability to self-provision their own VMs, but you don't want to give them the full access to vCenter. They just want to be able to have a single click to deploy whatever type of either Windows or Linux server or a fully provisioned stack with a full Oracle database, applications, Chef, Puppet, those types of integrations. VRealize Automation is the self-service tool for that.
All right. So let's take an example of how we could deploy, right, a two-node Oracle rack, or let's say an n-node Oracle rack using VRA and VRO, as Ryan spoke about, right? So essentially, let's look into this in a little more detail in this deployment flow, right? If you look at the top left corner, right, the end user essentially requests a service blueprint. What happens then is it triggers a VRO workflow requesting an Oracle rack blueprint. This workflow will then request the Oracle rack blueprint with passing specific deployment parameters, right? And that could be like the grid infrastructure, the home directory, the Oracle RDBMS home directory, the name of the Oracle user, the name of the grid user, right? The permissions, so on and so forth. And upon completion, right, it adds the Oracle rack cluster in the items tab. So the Oracle rack blueprint deployment, it starts a number of components. That includes a VRO workflow, which is started by an event broker, updating the VM network properties. It starts a VM Sphere component that performs a clone from a template for every host. And then upon completion of the cloning, a workflow will update the virtual machine hardware, right, to the controllers in the shared disk for the clustering. And finally, what we do is we run a workflow that orchestrates the Oracle rack and the database installation scripts on the different nodes of the rack cluster, right? So essentially, this is what the deployment flow is when we go to deploy an n-node Oracle rack, right? 2 is the minimum n-node Oracle rack using VRA, VRO. Moving on.
So now let's talk about hybrid clouds. And this is something that's important to us at VMware, is giving our customers choice. Nobody likes to be locked in or be told that's the only option. So VMware last year announced the support for the vSphere platform on a number of hyperscalers. Previously, we were only available on AWS, but now we have a lot of the other hyperscalers that run the vSphere platform. So if you're running vSphere on-prem and you want to be able to move that to the cloud very easily with the same vSphere operation model, as well as the performance and integrations that you've done, we've got Google Compute Engine or Google Cloud that it's available on today. That's sold and operated by Google. Also, vSphere is available on the Microsoft Azure platform. You can procure this from IBM Cloud, Oracle Cloud, anywhere it makes sense for you to run. It doesn't mean you have to run it on just choose one. You could also utilize multiple hyperscalers. So for example, if you have a few Oracle databases that have already moved to Oracle Cloud and you want to get some of those applications closer, they're running on VMware, that could be an option. But you could also use at the same time something like Microsoft Azure and AWS, depending on where your applications run and where your developers are utilizing those workloads. But again, the point here is we have vSphere running on all of these platforms. It's up to you where that makes the most sense to run. So going on about 4 years ago, we announced support for running vSphere in Amazon. So this is a bare metal offering that runs on the Amazon Web Services platform. So it's actually running in the same data centers that runs things like S3 and Lambda and EC2. It is a full vSphere stack. It's all hyperconverged, so all of the storage and networking is all built in to the hosts that are available. And then what happens is we spin up ESX, we carve out the local NVMe flash storage with vSAN, we present a data store, and then we use NSX for all the networking security overlay, and as well as the connectivity to your on-prem environment. And then we have a very fast connection from the VMware environment to any AWS service. So for example, if you're running Oracle databases in VMware Cloud AWS and the web front end is running something like Lambda, there's a very fast connection. There's also no egress fee. So take advantage of being able to build those cross-pollinated types of applications without incurring, any kind of fees between those two environments.
All right. So let's take a look at the example setup shown in the architecture diagram here. Essentially, this is a 3-site lab setup, right? That includes the on-premise site A, that's on the left-hand side. You have the site B on the right-hand side, and then you have the VMware Cloud on AWS, that's on the top, right? So the on-premise vSphere cluster on site A, that is running the production workloads. Site B is running the dev, the test, the DR workloads. Both site A and site B are in hybrid link mode, and they have access to their own dedicated storage. Site A is connected via layer 2 VPN to VMware Cloud on AWS. And in this case, in this instance, the VMware Cloud on AWS is essentially in a stretch cluster deployment. So it has 6 nodes in this stretch cluster. So 3 nodes on one AZ, 3 nodes on another AZ. And as Ryan mentioned before, the storage in the VMware Cloud on AWS, that's provided by the HCI vSAN instance. So this current solution designed and deployed 3 separate environments. So Site A has the 2-node production Oracle rack, right, PRD rack. Site A also has the production Oracle far sync, and Site B has the DR 2-node Oracle rack. Now, let's take a look at migrating standalone Oracle workloads from on-premise to VMware Cloud on AWS. So on a very high level, the Oracle workload migration from on-premises to VMware Cloud on AWS, that can be achieved in one of the 2 ways, right? Either one could use native VMware and Oracle methods, or one could use the VMware HCX, the hybrid cloud extension. So in this section, we will use native VMware and Oracle methods to migrate standalone Oracle workloads to VMware Cloud on AWS. So deploying Oracle non-rack or standalone workloads on VMware Cloud on AWS, that's exactly the same as one would do on premises. So as Ryan mentioned before, essentially the VMware Cloud on AWS, the ESXi hosts, they traditionally reside in an AWS AZ. They are protected by VMware vSphere HA. This use case deployed a single instance Oracle database that was on OEL 7.6 operating system. It was 12C, RDBMS and grid infrastructure. We use Oracle ASM filter driver, and essentially we made sure that all of the best practices for running Oracle workloads on VMware platform, that was followed in accordance with the best practices guide. Now, changing tack and looking at stretch clusters for VMware Cloud on AWS, right? Essentially a feature called stretch clusters for VMware Cloud on AWS that we have, which is actually designed to protect against an AWS AZ failure, right? So these applications can span multiple AWS AZs within a VMware Cloud on AWS cluster. vSAN fault domains are configured to inform vSphere and vCenter instances which hosts reside in which AZs. And essentially to increase clarity, every fault domain was named after the AZ it resides within, right? So one can deploy Oracle workloads on stretch clusters for VMware Cloud on AWS. And in event of any AZ failure, which essentially is very rare, the workloads are brought up on another AZ without any breach of SLA or RT or RPO, right? So one can essentially load balance workloads across multiple AZs. So the deployment and the migration of Oracle workloads from on-premise to VMware Cloud on AWS, that has been documented in detail, and that's provided in the reference architecture document. That's in the link at the bottom of the slide. Moving on. So the second use case we have here is essentially migrating a single instance Oracle database from on-premises to VMware Cloud on AWS. So the migration is essentially the same as we would do from one site to another site, from one on-premise site to another site. So essentially using the web client, we click migrate, we select the compute, the storage migration method, we select the compute resource pool, the storage, pick the destination network port group. And once it's done, voila, your virtual machine is now at VMware Cloud on AWS. And essentially we follow the same steps when we have to migrate back to on-premises from VMware Cloud on AWS. So, the blogs and the demo, they are provided at the bottom of the slide here. But
so one of the great features about VMware Cloud and AWS is that it does include HCX. HCX is actually a suite of tools that are borrowed from our NSX technology. But one of the things it does is it can stretch networks all through software, so there's no need to buy additional hardware or make any configuration changes to any of your on-prem environments, all software-based. And then one of the things we introduced that are, I think, critical for workloads like Oracle databases or any type of high-performing application is we have this ability to do bulk migrations. So a lot of VMs with a lot of storage, you want to pre-copy those, and then you do a warm migration from your on-prem to VMware Cloud AWS or back, for example. And then we've also introduced it using replication-assisted VMotion or the vSphere replication appliance on the back end. We can use that to utilize at the VMDK level, replicate the storage without any impact on the running operating system, and then do an online live migration over to VMware Cloud AWS, just like a VMotion. And then, as we mentioned before, the VMware Cloud AWS is not your only choice anymore. We have the ability for you to run the full vSphere stack on Google Cloud. So if you have a existing on-prem VMware environment and you want to move those workloads closer to, or just do things like DR or business continuity type of operations, you can run also on the Google Cloud platform. And then a very similar offering, just running in Azure, Microsoft Azure Cloud, is the vSphere platform on Azure services. So again, the same operation model, same performance, same integrations that you've done on-prem. It's the same vSphere that's running on bare metal in Microsoft Azure. Some things like HCX or the SRM components may not be included with these particular services. Also, this is sold and operated by Microsoft, so you would need to meet with Microsoft and then procure it from VMware. But again, it's the same VMware vSphere stack that's running in Azure. And then late announcement last year was we're also running the vSphere stack on Oracle Cloud. So if you've run or started to migrate applications or Oracle databases there, and you want to continue to run those on a vSphere platform, we offer the same stack, NSX, vSAN, and vSphere, all running on bare metal in the Oracle Cloud as well. Again, sold and operated by Oracle. You would need to meet with your Oracle representatives to buy this solution. However, it is running the same vSphere stack. Things, again, like HCX and SRM may be an additional cost. They may not be included like VMware Cloud and AWS, but it's something to discuss with Oracle on those matters.
all right. So to wrap it up, this slide provides a lot of licensing collaterals. Essentially, all of the licensing collaterals are hosted on the one-stop shop. And that is essentially a blog site that has all of these collaterals, including, the Oracle Best Practices Guide, the Oracle Rack Deployment Guide, the Oracle High Availability Guide, Oracle on vVols, Oracle on vSAN, Oracle using, let's say, persistent memory, Oracle with PVRDMA drivers, right? So, you could always refer to that. And that one-stop shop is essentially provided on this slide here. So the link at the bottom would take you to the one-stop shop. So as I mentioned before, all Oracle on vSphere white papers, including Oracle on VMware Hybrid Multi-Cloud, the deployment guides, the workload characterization guide can be found in the URL here. So that's a bit about me. A bit about Ryan. Thank you for attending today's session. We hope you found that useful. Please post your questions in the Q&A box. The session recording will also be made available to you after the event. So if you need more information, please, you can always reach out to us via our Twitter handles. And with that, thank you for your time today.